So we saw the outcome of the multivariate data analysis.
Mm-hmm.
How do we get to the point that we have those nice graphs that everyone should be able to read?
Quite a bit of hard work.
Yeah.
Mm-hmm. Yeah, and really, I think the magic is in the data prep.
Mm-hmm.
And this is why I harp on data quality, because I've done enough of this now that data quality is like a really, like big issue. Yeah, David, it's a lot of hard work. One of the things that we were very fortunate on this one in that the customer, this is why we believe in teaching, we've kind of shot the video on like teaching our customers to fish. We actually showed them how to build the event frames and kind of capture the data on a couple of different batch processes here. Okay. And if we hadn't done that and the customer one of their engineers hadn't taken the time, like he wrote some VBA macros and was like, okay, when this batch ends, look for the next batch after that in the next process downstream. Okay, those need to line up this way. And then he was doing some averaging of data, in the continuous processes, a couple hours after that or whatever.
Mm-hmm.
So he did a tremendous amount of work in getting all the data lined up for us. Okay. So that I want to make sure people understand that's a big deal. And this is still one of the reasons why I really have a ton of respect for the Pi system,
Mm-hmm.
is because it allowed us to get that summary data available and ready. Right? Whereas, like, let's say you had piped it to AWS, just a bunch of the raw data. Well, you still have to do all that math. You might have to look at the batch number and some of the timestamps and stuff like that. And it'd be a little more work, I think. That's what my gut tells me. And I know we kind of talk about this a lot internally, is sometimes it's a disadvantage to do all that configuration on the server side.
Mm-hmm.
But then sometimes it's a real advantage. Here I thought it was an advantage. Okay. And so, he had all the data prepped up, lined up, ready to go. However, there was still a bunch of data cleanup we had to do.
Mm-hmm.
Right. So, he had, like basically a batch event column. Right. Well, then he had one of the batches start and stop times. We don't need that. I don't really need the batch number. There was a bunch of places, there was a bunch more batch events, we're looking at some check column that I don't need. There was missing data. And then he had actually taken some lab data. So we had some lab data that was kind of missing. But it even gets better than that because, here's one where, we didn't have any data. We're looking at the RPM of something. And then in some of the lab data, when it was missing, it would go dash dash.
We've talked about this before.
Right. So I had to write a bunch of if-then statements to say if you see the dash dash,
Mm-hmm.
oh, wait, what do I do?
Mm-hmm.
Do I fill the data down? Do I interpolate between numbers?
Mm-hmm.
Or do I fill up? And, that's a choice you have to make. If you go watch any of the SIMCA folks' videos, they agree with me in that you fill down. Because basically, okay, this was my quality or this was my test at this point in time. I have to assume that's what I've done until I take the next sample.
Mm-hmm.
Okay, then that's my quality parameter, until I take the next sample. You can interpolate between them because you can make the argument that, hey, it's changing from what it was to what it is now over that time. I mean, you can do that. There's a couple of arguments you can make for other ways. This was just the way we chose to do it. And the thing that's very interesting about SIMCA, my friend that introduced me to this, he actually works at one of our customers. He actually said, you can actually do a data set merge in SIMCA. Like what they do now, like he did this in Excel with a macro where he was lining up the data. But if you have lab data that has one set of timestamps and then all this batch data that has a different set of timestamps, it'll actually do the fill down based on those two timestamps. It'll actually merge that for you.
Wow.
There's actually a data merge capability in SIMCA, which is huge. You know, here I didn't really have that choice because he already had it here. Because I went and looked at it after he told me, because I was telling him like about this thing I did. He's like, oh man, there's a cool data merge. Like, go watch that video. And I went and watched it. I'm like, this is really cool. I couldn't have used it here because it was already lined up. You know, so I had to do a bunch of if-then statements. I think there was like 80, 90 parameters I had to do this with.
Wow.
So I do it, you know, if you see the dash dash, then go look for the last good value and fill it in. And then I had to replace all those columns, you know, and then, so that was one thing I had to do. And then I had to do, you know, what we call feature engineering. So some of the things I did was I wanted to grab the year, month number, month. I even did, you know, in some cases like before, after, you know, we had good runs, you know, because like they were specifically looking at July through late September and then late September to late October. So I was looking at before and after potentially, you know, by date. You know, they had two major quality tests that we wanted to look at. And so I had to figure out, well, what was good and what was bad. And so like the one that we really got probably the best results on was this one that's somewhere in the 96 to, or 94 to like 98 range, right? And what I chose to do was say, hey, if we have a value over 97.5, that's good. Which they actually said, hey, Jim, that's really the top end of the range for us. Like that's really high for us. So it's like, you know, so realistically, I could have run a lower number there. But what I was looking for was trying to get a separation between what's good and bad, right? And if you draw the line at 97.3, if it's above 97.3, it's good, and if it's below that, it's bad. You're going to get a lot of muddiness, right, in that middle. You know, in that 97.4 to, you know, 96.8 range. And so what I really wanted to try to do, you know, I kind of just like looked down through there. I could have done some math and kind of gotten a distribution. I could have been a little fancier. I chose not to be. I just kind of eyeballed it. You know, okay, that looks close enough. You know, a real data scientist might have done that. But I just kind of eyeballed it. And so I said, hey, let's look at 96.9 and below is bad, 97.5 and above is good. And then if it's neither, then I'm just going to mark it neither. Right? And then I can use that as my class ID for my discriminant analysis. And then I can choose to ignore the neithers as I'm importing it into SIMCA. So that's kind of the nice thing. So it'll have three classes, good, bad, and neither. But I'm choosing to ignore one class of neither. So it'll eliminate all those rows that say neither in there for me as I bring it in. So, you know, I had to get rid of all the junk, you know, which I didn't actually. SIMCA caught some more. And then I had to do a little bit of feature engineering to give me the discriminant groups that I wanted. So I did it on the two different quality parameters, and then I did the before and after. So I had three kind of different questions I wanted to ask. What's different between before and after? What's different between good and bad on the two different quality parameters? So I wanted to run all three of those analyses. We're just going to do one today. All right. So let me take a quick look here.
Now, is feature engineering inclusive of the data cleanup? Or is it data cleanup, then feature engineering?
But it's both.
Yeah, okay.
It's more the latter. Yeah. All right. Yeah. So I'm going to use this July to October data set. I'm not going to do the all year one. Actually, no. I'll do the all year. How's that? I'll do the all year one. All right. So we're going to start a new project. So once I kind of have the data all prepped up, right? So I'm going to do the data set. I think I just called it data prep for SIMCA. Hopefully this will work correctly. No. And it does not. Okay, so I'm not real sure what's going on here, but there's actually data there, and we'll see it here in a minute. All right, so some of the things we have to go through is the batch event, that first column, is actually going to be our primary observation ID. That's what we're going to kind of call it, and it has kind of a date field, right? So that's the first thing I'm going to do. One of the things that I want to look at is the this particular column is my good or bad. I'm going to make that my class, right?
Yep.
Is the good or bad. That's that quality parameter that I want to make good or bad. And so let me go through here. Like the crew should be qualitative because it's text. Crew at start should be qualitative. And if I could actually see the data, then I would know. I really do not know why that's happening. Let's see if there's any other oh, there's a couple other qualitatives. And actually, I'm going to take some of these other quality tests. I'm going to exclude those.
Okay.
Because all they are is just confirming, right? They're not going to tell me anything more. They're just going to like show the model like, yeah, this is really correlative. Yeah, I already know that, right? So I'm just going to go ahead and exclude those. I'm going to exclude this before and after bad runs because I'm not using it for the whole year. Let's see. The month is qualitative, month number is quantitative, the year is quantitative. So I don't think I had anything else. So I've got some issues, right? So if I go to it, now I'm going to start to see data, interestingly enough. So like here I have a calc failed, right? So I can either treat that as missing, I can exclude the whole row, or I can exclude that whole column, right? So I'm going to choose to treat as missing. Okay, so I'm going to go to the next one. Yep, treat as missing, treat as missing. And what's interesting is it's telling me like for every row, like how much data is actually missing out of that row. Right, so like here's a batch that I have like 17% of the data is missing, right? I might choose to exclude that whole row potentially, right? I'm not in this case. All right, so I'm going to keep going. You know, I'm going to treat all these as missing. You know, and I bet if I scroll up, I don't think it fixes it here as we go along. But what I'm going to do is I pretty much know the pattern now, right? And I'm not going to sit here and continue to run through it. I'm just going to go ahead and tell it to resolve all of them, right? So now you can see it has put all zeros in there. And you see I still get this weird gray box. It's probably a feature they have fixed in the latest version of SIMCA that I have not chosen to install and put the license on the folder yet, or on the file yet. All right, so now we have no issues. And now what we can do is we can actually finish the import, right? And so I'm going to call it Jim and Dave. Okay. So now it's saying, hey, what kind of a model do you want, right? Do you want to do principal component analysis? Do you want to do partial least squares or orthogonal partial least squares? Do you want to do a discriminate analysis, the DA? And I have not seen what the difference is, and I don't know what multi-block and hierarchical models. I have not been trained on those, so I'm not really sure what they are. So you'd ask me like what all the algorithms were, but so there's basically 5 sets, right? So I'm going to do this discriminant analysis. Okay, so I'm going to go ahead and select all of those. These are all my X values. I think I can I do a control A? Yeah, I can do a control A. I could choose to exclude any of these if I want right from here, right? You know, so like if I want the month, I want to exclude that, I can exclude it because I've got the month number in there too, right? All right, so let's go ahead and do that. Now, if you look, I've got the class as neither good or bad. So like let's say I want to look at the neithers, okay? I want to exclude those. Right? I want to go find the goods. I want to include those. Okay. I think I hit include. And let's find the bad. And include those too. So now I've excluded all the neithers. So because what I'm really trying to do in a discriminant analysis is get separation between good and bad. Neither is just going to muddy the water. Okay, neither really isn't telling me anything because it's kind of middle of the road. So what I'm really trying to do, and this is why I picked the numbers I did, is because I'm trying to get those numbers different enough where I can get that separation in that 3D space or that 2D space. That's really what I want. Okay? All right, so let's see what's next. All right, so what it's going to do is, hey, there's 680 observations, so 680 rows, okay? And there's 185 X variables, okay, which are the columns, okay, because I've excluded some. Okay, and they're in 3 groups, one of which we've excluded, okay? All right. And so now I'm going to go ahead and do the OPLS DA, okay? I mean, I can do a PLS DA or this one PCAX model. I don't know what that is, but whoops, I'm going to do the OPLS DA because that seems to be one of the most effective ones. And I'm going to choose to go ahead and auto-fit it.
Yep.
Okay, as it comes in, okay? So I'm going to go ahead and finish. Now, it's going to say, hey, the year has no values different from the median. I probably should have excluded this column. So you know what? Do you want to exclude? Yes, I do. Okay. Hey, this particular one only has 2 different values from the median. Yeah, might as well exclude it because it's not going to tell me anything. This one only has 2. Okay. This one has 0. This one has 0. That one has 0. So you know what? I'm going to exclude all of those. Okay. So now what it's going to do is it says, hey, I've got 3 basically dimensions for you, okay, because it's trying to break these down into dimensions. Okay, and so if I look at scores, I've got good and bad, okay, but I've got a lot of overlap here and I've got some outliers, okay. And if I use the up arrow key, I can look at the other dimension. I've got a lot of real outliers here. You know, if I want to look at this in a three-dimensional model, you know, there's my ellipse of most of the groupings. I've got some that are like way out here in left field, right? I gotta go see what's going on there, right? What we're trying to do is get rid of some of that stuff, but we want to do it with some thought, right? We don't want to just say, oh well, that's crap data, get rid of it. Well, you don't know. Just looking at this. All right, so I'm gonna go ahead and kill that off. There's also a loadings thing. So remember we were kind of talking about, you know, doing like the X and Y. So what it might do is it might plot a Y kind of on this 0 axis right here. And so the things that are, you know, very close to it are actually driving it good or bad. They're very correlative. The stuff in the middle is almost not correlating at all. Okay. So, you know, in a PCA analysis, we're going to be looking for that, especially when we're doing Y compared to X. Like if I wanted to look at this quality parameter as the Y, which X's seem to drive it, then I would be looking more at this kind of a graph. Okay. And here I'm not. So here I'm literally looking more at the discriminant, like between the 2 groups is really what I want. Okay. So that's another kind of a thing here. All right. So there's 2 kinds of mathematical operations that you can do. One is called the Hotelling's t-square. Okay. And then the other one is d mod x. Okay. So we're going to look at those, and this is going to help us find the outliers. Don't ask me to explain the math. I don't understand it. Don't ask me any more about it. If you want to go look it up, you can go look it up. Anybody who's watching this, you can go look it up. Okay. I don't know. This is like, if you're a true data scientist, you're probably like pulling your hair out like, why don't you understand this? Look, I'm more of a controls engineer. I'm using these tools. I'm trying to find the outliers. As long as I know this helps me find the outlier, that's a good thing, right? So don't get on me. Don't hate on me.
I'm not sure how many data scientists are going to
Hey, I've been connecting with a lot of data scientists on LinkedIn, and they're probably going to be very disappointed in what I just said.
Throw a lot of hate at us?
Yeah, they're going to throw a lot of hate at me. Okay. You know, you don't know what you're talking about. Okay, but the reality is these tools, I don't necessarily have to understand the mathematics behind it. I do have to understand this is why I use it. And then, so what I'm looking at here is, this is kind of the mathematical, the t-square calculation on all the different batches. Okay, and you can see there's several really big outliers. So what we're going to do is we're going to go, like, this is This is a batch that was run May 29th around 9:12 p.m. That's when it started. Okay, so if we look, like the wait time was way out of whack. Okay, this particular step time was way out of whack. That receive time was way out of whack. They waited at the reactor. They waited at. This was probably a flow. It was way out of whack, or was a wait. I can't remember. So there's a whole bunch of stuff just way out of whack, right? Compared to normal, right? And what it's saying is outside 3 sigma, right? That's the yellow coloring.
Wow.
So there's a whole bunch of stuff that's just really jacked up in that one, right? So let's double click on this one too. This one was probably back like February. Kind of same thing. We have a whole bunch of stuff missing.
Yep.
So I've already done some of this analysis. I can pretty much tell you these are just like way out of whack and they're going to throw your model off. Okay. So what I'm going to do is I'm going to go down to this red line, which should get, I think it's like 99%. Okay. And it's drawn some cool little histograms and stuff. And I'm going to say, hey, I'm going to exclude those. Okay. So it excludes those and says, oh, guess what? You have a new model now. Okay. Right? So I took you from 680 observations down to 670. Okay. So now I've seen a lot of the SIMCA guys, they'll do like two components first and they'll add components. Mm-hmm. I was taught just to use the auto fit. Where you get into trouble is when, you run it and it has 28 components and it takes like 10 minutes to run.
Yeah.
That means is really struggling to figure out, any kind of relationships here.
Okay.
Okay. So when you see something that has lots and lots of components, it's not going to be a really reliable model. Okay. And I'm going to show you something else here on this. The other thing is you're looking for a higher score. The higher this score is, the better chance you have that there's correlation here. Mm-hmm. So like if you have 28 components and nothing's higher than 0.3,
yeah,
you have a really muddy model and you're not going to really find a lot. You're going to have to eliminate some things. Okay. So anyway, we're better. Okay. This is good. So let's look at the scores. Okay. I don't have quite so many outliers now. Okay. Not too bad. Okay. I do have some separation. Okay. Let's go back to hotellings. Okay. Same kind of thing. I've already done, some of this research, so I'm not going to bore everybody, but I'm going to come down just below that line. Okay. I'm going to exclude those. I'm going to go through this same process. I'm trying to weed out all the outliers that are going to drive the model nuts, right? So I've got, I've still got some outliers. Okay, so I'm going to get rid of some of these. Okay, I'm going to rerun hotellings. Oops. Make sure I actually have the right one. I'm going to do a hotellings on this one. Okay, so we're looking better. We're getting things kind of in this. I'm going to come down. I'm gonna get some of these, and like I said, I've done the research. And hey, here's one. It only has 2 different values. Yeah, I'm gonna exclude that one. Right. Okay, so auto fit. Okay, we're still in 3 components. Our scores are pretty high, so this is good. Okay, I have a lot less outliers. I'm starting to see group separation here. This is good. Okay, hotellings, we're all below the red line. We're all below this 99% threshold. If I want to get below 95, I guess I could do that. Let's just try that. I don't think I did that on any of my runs. So I can exclude this. So basically, we're just getting rid of outliers here, right? So now I've gone from 680 rows of data or observations down to 631. Okay, I'll auto fit that. Okay, again, staying in pretty good, 3 components. Okay, let's take a look at 3D, how this is looking. Okay, so it's interesting because I do have this outlier, which we remember that was January.
Yep.
Right. Okay, this was October. Right, and what's interesting is we actually see some separation in October. They're pretty independent. Right. I don't think I ever tried to separate them this much. So let's go look at scores. Now this is a 2-dimensional space. Right. So this is like looking at it from 1 dimension, then it's flipped 90 degrees, if I remember right. Okay, which is what helps you build that 3D model. Okay, so anyway, we can kind of see you know, see some separation here. You know, some of the things, you know, let's go in and let's look at the D mod. You know, here again, you know, we're gonna, you know, we try to do our research and say, oh gosh, you know, we got, okay, this is the reactor pressure was way out of whack, the temperature was way out of whack, you know, there was a co-feed flow that was way out of whack. Yeah, that's probably not going to be really conducive to having a good model. So let's knock off some of the stuff kind of along the top here. And the thing is a good data scientist looks at a lot of this stuff, but here's where the data scientist doesn't necessarily understand. Like, okay, you know, what is that co-feed flow? What is that wait time? Like, they don't really know. Since we've, you know, a lot of us have been controls engineers, we've been around plants, we can kind of say, you know, that's probably an outlier. You know, if it sat and wait for very long, or, you know, the temperature was like really high compared to normal, that's probably not going to be a good one for us. So we'll go ahead and exclude some through the demod process as well. Okay, auto fit that. And if any of you from SIMCA are watching this and I'm completely explaining this wrong, I'm really sorry. I'm trying to explain this to a more lay audience. I'm not trying to get too technical. You know, so I'm not trying to be, you know, and plus I've never really studied the math behind it, right? I'm trying to eliminate outliers. That's the message I'm trying to get across. So don't hate on me, please. So now, you know, if we kind of look at the scores, you know, we can kind of see, you know, we've got one more component, you know, that we can look at. Let's kind of look at it from a 3D space again. You know, but the thing is, we don't have like those ones that are like really big outliers here, right? You know, I do have some that are kind of outside, you know, like here, you know, and here. So like one of the things, like if that really just drives me crazy, like, you know, some of the things I can do, like let's say I want to get rid of all of these.
Okay.
I can actually highlight them, and let's say I'm going to hold down control. I'm going to get that one. I don't know, are there any others now? All the others look pretty good, right? So I'm going to exclude those. Now, what we already know about January is their airflow was really high because they had a sensor problem.
Yep.
Okay, we already know that because I've already run this model. That was one of the main reasons why that set of data looks so different. Okay. All right, so let's look at the scores here. Okay, we've got some new outliers because we reran the model. You know, we do have a new hotellings because we reran the model. And you can sit there here and do this like ad infinitum, right? You know, but the reality is you're trying to get, you know, good data, things that are not going to throw your model off, right? So I'm going to auto fit. Okay, I'm going to get rid of some of these here. And you see that it's got Model 5, Model 6, you know, so I'm going to get rid of some of this older like Model 5 and Model 6 stuff, right? Because I think we're probably about Model 7. No, we're on Model 8 now, right? So we're on Model 8. All right, and you notice we did pick up one more dimension there, or one more component, right? So I just hit all the scores, and this is like our score plot. You know, this is our loading, so it kind of tells us like correlations, you know, and some of the XYs, and then there's a, you know, a D mod X. So I'm actually kind of getting okay with some of this, but let's just say we really want to get some of the separation out of here. So maybe I take some of this overlap where I've got some goods and bads, get the Democrats and Republicans out of here, right? Red and blue. So since we just came out of the election and we all seem to hate each other because we don't have the same political affiliation. Okay, which I think is stupid, but anyway. All right. So now I excluded all that stuff in the middle, so now I should have a little bit more separation.
Interesting.
Okay. So if I look at that in a three-dimensional space, okay, actually you can almost see three clusters starting to show up. You got one there, and one there. Okay. I mean, that's almost kind of, well, actually four.
Yeah.
Because you got this one, which we know that one's January. Right?
Interesting.
Okay. So let's get rid of these couple. Let's see, actually, I'm going to grab kind of all those in the middle. How's that? Exclude those. So again, what you're trying to do in a discriminant analysis is you're trying to get to differences. and what drives those differences. That's what that's your goal here. All right, so now I have separation. Okay, if I really wanted to, I could, you know, kill these right here, right? So let's just do that. Okay, right there. Okay, let's exclude those. You know, and sometimes, man, when you're running auto fit on these, like, it gets forever. And you see now we're up in like the 9s, right? Because we've eliminated all the stuff kind of in the middle that could be good or bad, that there wasn't a whole lot mathematically different between them. Okay, so let's take a look at this three-dimensionally. Okay, so now we have definitely two groups of bad. We kind of have maybe really three groups of good. You have this one, and then these over here, right? So let's just say, let's go look at that scoring.
We're on model 11 now.
Yeah, I know. So I'm going to get rid of some of these older ones. Okay.
And for all the data scientists really upset with Jim, whatever month this comes out is really beautiful in St. Augustine.
Yeah, exactly. All right, so I did month number. Now I'm going to change the properties. I'm going to go to color. I'm going to make this a category 1 to 12 with 11. I'm going to add that and hit apply. All right. So now we've eliminated a lot of the January runs. Okay. That we have February, March, April. We kept most of those because, remember, we already knew that they were pretty similar. Okay. We eliminated some of the transition in May because we saw some of the transition. You know, we eliminated most of June. You know, there's some good runs in June. July, which was really probably their best month, you know, January and July, we kept most of those. Okay, August, we could see the transition in August and September. Okay, you know, and then we have October, which is a very distinct difference. So, like, let's say I want to look at July versus October. Okay. So October's bad, so that's red. You know, that's why I clicked on July 1st, because I knew it'd be blue. And then I can do a group-to-group comparison between those. I'm going to sort those as ascending, and I'm just going to eliminate a bunch of this stuff. Not eliminate, but I'm going to hide it. I'm going to hide. I mean, I could exclude that, because those are not driving things, right? And then rerun the model again, right? But that's okay. So we have a couple of the other color ones that was one of the quality tests, which I probably should have. I've eliminated in other ones. So let's just go ahead and do that. Let's see if that's one of them too. Yep. Okay. Let's go ahead and exclude those, because all they are is confirming they're part of the same test, quality test. It's a color test. And so all they're doing is confirming what we already know. Take it out of the model. You don't need it. Because all it's doing is contributing to that separation. Okay. So now I bet when we auto fit that, it's going to look quite different. I bet it's going to get muddy again. And you see the scores. Well, the scores are still pretty high. Okay. We got a little bit more muddiness. Okay. That's okay. All right. So let's go back to month number. Color, category, 12 by 11, add and apply. All right, so let's look at July versus October. Do a group-to-group comparison. Sort ascending. Let's see. Let's go there to there. Okay. And I'm just going to hide it this time. I'm not going to exclude it. All right. So we have this particular differential pressure. Okay. There's blue versus red. Drastic difference. Okay. July to October only. Not good, bad. Just July to October. But what's interesting is I made a step change back here in August 20th. on a particular batch number, okay, batch number 1496, they made a change. Drastic change. Okay? We didn't have problems till like September 23rd.
Mm-hmm.
Right? But you can see they're running very differently than they were back then. Okay? So that's one thing. This is why multivariate is important, because that's not the only contributor. Well, maybe this one also had something to do with it. And I don't know what this one is. This was another differential pressure, okay, in one of their feeds. Okay? So again, it went up as well. Okay? Let's see, what was this one? That was another color one. The cycle number that has nothing to do with it. Okay, there's an outlet temperature. Okay, lost the sensor. Mm-hmm. You can see a flat line because, hey, we were about the same. Sensor problem. Okay, could probably eliminate that one, mm-hmm. right? Because that sensor's been pretty stable all year long, right? So that's probably not a problem. Okay, but you can see why it contributed, mm-hmm. right? So this is one of these correlation, not causation kind of things, right? Let's see. Here's a gas rate. Okay, and we can see this was around October 20th. Okay, it was starting to go up, and then it got really crazy. It got kind of unstable. Okay, but it was starting to trend up. Okay, over from July up into October, which they were actually very curious about this one.
That is interesting.
Okay, because it got noisier. It was starting to trend up, then it got really noisy, starting about October 20th, right? So, this is kind of the way we attack these kind of problems. And, we could have done good versus bad, but I thought the July to October, which was, mm-hmm. We saw was a good versus bad month. And just in case of, video editing, I'll go ahead and pull that file up in Power BI, just to kind of confirm. And show people like, hey, we looked at this, and what we found was that their performance in July was really good. Their performance in October was really poor, right? And sorry, my wife is leaving out the garage, so if you hear growling through the my office, it's over our garage. Sorry. All right. So April, pretty bad month, right? July, really good month. October, pretty bad month, right? So it would be interesting, to see that. Now, how about we take model 12 and let's look at April versus, let's do it the other way. Let's do July versus April, so that way April's bad, okay? And let's do a group-to-group comparison, right? I'll sort that ascending. Okay. And we'll see because it's going to be a different answer. Mm-hmm. All right, so that's one of the color ones. They have an unload step time that changed, okay, that dropped down. Okay, that's one thing. I'm not sure what this is. I can't remember what that was. I think that was another lab test, but it did come down.
Interesting.
Okay. Let's see. What this one is on the other side. That was another lab test, right? So that had come up from, July was much better than June. That was probably more just confirming something they already knew. That's probably not telling them anything. The cycle number has nothing to do with it. I should take that out. This may be like a water phase step time or something like that. Okay, it's up a little bit higher. It's kind of running just under 150 minutes, and now it's probably over, 250 when they're doing well. But again, you can see that it was a different set of things that was driving it mathematically different, right? But the thing is some of the stuff we already see, that has nothing to do with it because that's just another one of the same color tests. It's just a different part of it. Or it's the cycle number. I should have eliminated that, right? So that's why sometimes I think a data scientist really kind of struggles because they don't really know. Mm-hmm. Like I know that, like when I see cycle number or I see those things, like, I know, that's the same thing, or it has nothing to do with it, right? And so I think it's going to be very important as time goes on for these kinds of tools to be able to be used by somebody like me. I don't have to know all the math behind it. I don't have to know how the algorithm works. I just have to know, does that algorithm detect the kind of problem I'm looking for?
It's very interesting. No, I agree. I think that it's I agree. I think it's very interesting. It's just an extremely powerful tool, right?
I think so.
We've all sat here and kind of watched as you've gone through and easily eliminated in a way that I would imagine the majority of people watching this could go through and take process knowledge to go through to understand, what's important and what's not, or at least going through the AutoFit a variety of times, eliminating outliers, and then once we've eliminated outliers, looking at the difference in variables. Now, it's not nearly as easy as, the 25 minutes of you just going and cutting things and dragging tools down. I think we should throw that out there.
Yeah, you have to do, I spent enough hours like studying, can I take that out of the model? And I did some things in this video that I might not have done because I was trying to, look at something a little bit more definitive, but now that I've been through it, I actually had some different questions. I'm like, well, what happens if I take all the ones that are a little bit muddy, that are kind of transitioning good to bad, right? And it was very interesting, to see the differences. One of the things that I'm trying to still understand and wrap my head around is that grouping down in that bottom right quadrant, is all April, February, March, April, which they ran progressively worse. They didn't really change a lot.
It was all,
it's all
right
pretty
there.
well grouped.
Yeah.
They didn't really change a lot, but yet they got worse. Why? Was it feedstock? Was it, what was it? Was it because the air was getting, a little warmer and they didn't make adjustments? I don't know. But they got progressively worse over those 3 months. Why? Because not much changed from a process control standpoint. I can see that. Right? I don't have to know the process to see that. And to me, those are I think the powerful tools, in this is even me, not even being a process expert, can then go back and ask the process experts some really pointed questions. Like, I see you guys ran pretty much the same. Why'd you get worse? Hey, I see, and we saw this, like I showed Dave this off camera. In January, we had an airflow sensor that was reading incorrectly. That's why you see all that stuff over on the bottom left. You almost have to take that out of the model because it's like, well, they had a main airflow sensor that was reading almost twice what it should have. That's a problem, right? And so I think you can start asking different questions of the process people. And one of the questions I ask is like, well, you guys aren't real disciplined and running the same way month after month, right? This showed me you didn't. And what was interesting is the process engineer, he's like, I need to study on that a little bit. He's like, I see your point. But, now look, to be fair, okay? To be fair, they're continuously trying to improve and run faster. So of course they're going to change things.
Yep.
Right? They're trying to get their cycle times down. They've been constantly working on it. So they're going to change stuff, right? And so that Z pattern didn't necessarily really bother me. But at least let me poke them a little bit and go, are you disciplined enough? Do you understand what you're changing when? And I think they even said to themselves, I'm not sure. We need to go study that a little more. And I think sometimes that's some of the questions that are really great that come out of these. You may not find the answer that you were first looking for, but you find a whole lot of stuff that is really interesting. And like I showed you that October 20th date, you could see it in the data. You could see it.
You can see it in the data. And one of the things that's, amazing, Jim, is we're sitting here literally doing this on a laptop that you could, in theory, go to Best Buy and purchase, right?
I did. That is bought at Best Buy.
Go to Best Buy, you buy a laptop. It's 2020. It may be 2021. And we can now run something more powerful than we could have even considered 5 years ago, right?
Yeah, for sure.
5 years ago, 3 years ago.
Yeah.
Like, this is, you know, it's living on a supercomputer. It's living in the cloud if you have access to it.
Yeah.
And now you can literally go to Best Buy, purchase the license, and go through, look at something like this. And I mean, you can do some sort of ROI calculation and figure out when it makes sense instead of like going through the process of guessing and checking to try to ramp up your speed to go run a series of DOEs and figure out how to get there.
Well, the thing is when I asked the process engineer, you know, does this help you? He remembered all the things he had to do to try to do this before. And he's trying to put a bunch of stuff on trends, and he's got a bunch of screens, and stuff's all over the place, and he's pulling data into spreadsheets, and he's trying to figure it out. This, and I cannot overemphasize this, if their other process engineer hadn't gotten all the data lined up for us, we wouldn't even be shooting this video. We'd still be working on getting the data lined up, and we probably wouldn't have done as good a job.
No, I mean,
because he knew the process, he had all the event frames configured, he lined everything up, which gave us a tremendous starting point. I still had some cleanup to do. Okay, that's fine. That's fair. But he saved me weeks of work.
Oh yeah, a couple of weeks worth of work.
Yeah. And so the reality is we had a great place to start, you know, and now we can eliminate things extremely quickly. I mean, how long did that take? I mean, we've been shooting for 37 minutes since I started hitting, okay, import into SIMCA. You know, now, granted,
we've eliminated things so quickly. No one from SIMCA is currently still watching the video.
Yeah, yeah. But here's the thing: is I had done enough research and I had spent enough time with this data set.
Yeah.
And it double clicked on all those peaks in the hotelings and the D mod to know, yeah, these are outliers.
Yeah.
I already knew that, right? Now here's the reality: if the first time I ran this model, I spent a lot more time looking at that and trying to get an understanding of what does this really look like? What is this trying to tell me? Can I eliminate it? Can I not? So once I did that, yeah, then you just breeze through it. You breeze. So anyway, I agree with you. I think this is an incredibly powerful tool, and these kinds of tools are unbelievable. You know, sometimes I think the one I'm still kind of looking for is sometimes I'm really not sure what I'm necessarily looking for. I need to just go throw a bunch of data at it and tell me, like, what does it see? Like, what are anomalies in normal operation? And I know there are some algorithms out there that do it. There are some companies that have kind of focused on that, and I haven't seen enough of that to make a determination on like where we're going to go and where we're going to use it. I mean, I think, you know, somebody like Seek has done it. I know the guys here locally with Sorba have done some things on that regard. I'm trying to think. There's a couple others that Falconry had done some, but you know, at the time I last looked, I haven't seen anything from them in several years now. But you know, they were trying to point out to you, like, here's an anomalous condition. This is different than any other time you ran, right? And some of that you got to go eliminate. Like, yeah, we had a major plan upset. Like, that's not really. Yeah, I know that, but I need to eliminate that. Like, I need the anomalies of when I'm trying to run well.
Yeah.
Right, and I think that's probably the next step. Trend Miner may be another one that, you know, that's kind of gotten some stuff done on that. You know, and those are things we're going to continue to evaluate. I mean, we've looked a little bit at Seek. I've actually looked quite a bit at Seek. We haven't looked at Trend Miner enough. You know, we did some stuff with Sorba. You know, I'm not sure where we're going to land on some of that. I know what this tool can do, and I know there are certain problems that I can solve with this one.
Yeah.
There's no doubt about it. Yeah, I think this is what every engineer is going to need, these kind of tools going forward. They're going to need something like this to help them eliminate ground and eliminate the things that can't be causing the problem. And help them pinpoint the things that might be causing their issue. You know, because the reality is some of that stuff we saw was different between July and October may mean nothing. It may be the number of lawyers versus milk drank in Mississippi or whatever the heck the thing was, right? It may be that, right? But they'll know that part. But if they can at least get down to those things,
Mm-hmm.
you know, I would think it would save them a ton of time.
Yeah, and I would say, you know, the process for someone to take their data, build it into a data set, and send it to you, that for them is probably a doable task. And then have someone who's a, you know, expert on the data side, expert on the multivariable analysis side, go through the process and do this because you guys work on something like this, and then give them back the top dozen-ish
Right.
things so they can go look at a dozen. I mean, that is a very simple workflow that is going to save you guys weeks of work because you don't know the process side as intricately as the process side does.
But here's the issue we usually run into. This was an anomaly in that the engineer knew how to get the data prep because he had run SIMCA and Pro MP. So he knew how to get the data prepped.
Mm-hmm.
Most engineers were like, hey, give us a bunch of data. They wouldn't even know where to start.
It's a different issue.
Well, and one of the things, like we looked at a problem for this company too, you know, several years ago. The first passes we said, you know, we took like 3 years of data for 1,000 tags at a 1 hour interval. The reality is we needed about 200-300 tags at 1 minute to 5 minute intervals to find the problem.
Mm-hmm.
But you don't know that going in. And so if we just ask them, hey, give us a bunch of data, we may never find anything because it's missing. Because the problem happens in a 15-minute stretch that we get an hour chunk and we get here and we get here and the problem happened in the middle.
Mm-hmm.
So it's not so simple to just say, hey, Mr. or Miss Customer, give me your data. We got to get in there and dig around with the process experts to help understand. Usually we're going to pull the data.
Mm-hmm.
In this case, this guy had it, he knew it, and that's why I couldn't overemphasize enough how important that was for this one and the speed at which we were allowed to work.
Mm-hmm.
That is very rare for us.
Okay. So it's almost
But
like
it's also why we taught them,
right?
But it's why we teach them to fish.
Yeah, so it's almost like a data scavenger hunt.
Yeah,
Okay.
it is a data scavenger hunt. Exactly.
You know where you need to get, and we showed everyone where we ended up, and that's basically where they needed to be.
Mm-hmm.
It's just all of the processes in the middle that, you know, we skip 6 weeks worth of work.
Exactly. That nobody has anymore.
Right?
So, all right. Well, I think we have beat this one to death.
I think we have.
All right, let's wrap it up. But hopefully you guys learned something. There's plenty of videos, you know, about, you know, how we got here, like what the customer challenge was, kind of what the end result looked like. Yeah, this was more how to build it. So, you know, appreciate you watching. If you've made it this far, because we're probably going to release one long form video. If you made it this far, there's something wrong with you probably.
If you made it this far, tell Jim.
Yeah, I'll get you a pen, you know, some stickers, and a hat. I promise. I promise you. If you made it through the whole video, at one sitting.
Right.
And also, this is something I don't ask for very often, and I watch a lot of YouTube stuff, and everybody says, you know what, if you like the content, like and subscribe. I never ask anybody to do that. I always forget that, don't I?
Yeah, I think that's the difference between channels like this, that the goal is to teach people.
Yeah, versus they're trying to get watchers and monetize it, right?
Yes.
I'm not trying to monetize my YouTube channel.
Yeah, I think we're about 1,000 subscribers away from or
Even
800
close.
Subscribers away from even being close to.
And the watch time is not anywhere near. Yeah.
Yeah.
So I'm not worried about monetizing. This is literally to teach, to educate, and to, you know, and for us to gain some credibility. Like, hey, we actually are pretty smart people. So anyway, but hey, like and subscribe. I would appreciate it.
Yeah.
So thanks a lot. Appreciate y'all watching.
Thanks, guys.